Okay, so today we're going to start on 10.6, which is probability of a type 2 error. Okay. Up to now, we've been mostly focusing on type 1s. If this 3 is true, this will be the most missed problem on your next test. Okay, this one is a little bit trickier. So you may want to study this if you want to get this right. Okay. So just as a reminder, a type 2 error, usually we use Roman numerals, is the probability that you do not reject your null hypothesis when, in fact, the alternative is true. Okay? Now, here's what I would like to say. You do 3 steps. Number 1 is find the value, which could be 2 of them, that leads to rejecting the null. So you have to know what the null is. Number 2, draw a picture. And then number 3 is find the area of the type 2. Okay?
I have a quick question.
Yes.
So, like, why are you accepting the null hypothesis?
Oh, he just used the A word. Did you hear that? Wash your mouth out.
Why do you not reject the null hypothesis in the first place? Is this like before doing the experiment, you think the null hypothesis is correct?
Okay, so let me give you an example. Yeah, it's a good question. It's a really good question. Why would you not reject the null hypothesis? So let's say, for example, you and I were having a bet. We're flipping a coin. Comes up 7 heads. We do our p-value, and our p-value is like, say, 0.10, let's say. I'm using an alpha of 0.05. And you tell me, you're trying to play it safe. You don't want to lose my friendship, okay? You don't think there's enough evidence to accuse me of cheating, okay? What if I was cheating? You just made a type 2 error. I was cheating. I put tape on the coin or something. You didn't notice. Came up with 7 out of 10 heads. It's some evidence, but not enough. Okay? Does that make sense?
Yeah. And so are we trying, like with these types of things, are we trying to identify when a type 2 error occurs? Or
right.
Like how is this coming into play with our statistics?
Yeah. So let's do an example, and that'll probably help. So I know it's been a week. We've probably forgotten this. So let me just kind of remind you, this is an example we did in class, clear back in 10.2 example. Okay. So we tested the null hypothesis was that p equals 0.5. The alternative was p was less than 0.5. The idea here is we were trying to decide if Illinois students were prepared for college math. Okay, so the null was half of the students are prepared. The alternative was less than half of the students were prepared. Okay, so now the one thing about the null, remember, the alternative hypothesis is just, it's very vague. It's just less than. Okay. So you need a specific value in order to calculate a type 2 error. You can't leave it vague like this. So our new hypothesis is going to be, our alternative hypothesis is going to be p equals 0.48. Okay? So let's see here. So the idea, all right, and this is where drawing the picture, let me just say that here's the frustrating thing about this. I think I mentioned this in class before, but I'll mention it again. It's been a week. You guys forgot anyway, right? So I used to allow people to use Microsoft Paint because this is more than likely, well, no, I could put it on the written test, but there would probably be a computer test question like this. And the testing center told me that you students are very good at cheating and they will not allow you to use Microsoft Paint on the test. Okay, so if you open that up, I'm going to get an email saying you were cheating. So don't open it up. Okay, but you can have scratch paper, or I would say this: if you want to draw a picture in Excel, you can draw it. It's just not the easiest thing to do, and I'll demonstrate that in a minute. So the idea, in fact, I almost should put draw a picture first. Maybe I should make that the first. You know what? We're going to change our steps here. This is going to be step number 1. That's going to be step number 2. Okay, I've changed my mind here. Okay. So the idea here is we're going to draw according to the null hypothesis. Okay? What is the mean of the null hypothesis in this case? 0.5. Okay? All right, so we've got this here. Now, we need to find the values that lead to reject the null. Okay, so now let's see here. Is this a one or a two-tailed test? It's a one-tailed test. It's a left-tailed test. Okay, so I want to find whatever this value is. How do I find that value? We're going to assume our alpha is 0.05. Now is where we got to shake off that rust in the tournament. Ashley, you remember? No. Franco remembers. Jacob remembers. Oh, come on. Anybody remember?
There's a long break.
Sean remembers. Not anymore. Okay. Remember, there's a test this week, by the way. Thursday, Friday. No, Wednesday, Thursday, because they won't let me end it on Friday anymore. So it's going to be Wednesday, Thursday.
So are we going to use the alternative in that situation?
No. Well, we're going to use the alternative, but not yet. Okay. So the idea here is we think the mean is 0.5. We've got to figure out what this value is. What's our favorite equation? Z equals, well, I was going to say x bar, but we're using not x bar, we're using p hat, right? It's going to be p hat minus p over the square root of pq over n. If I were using a mu here, I would use the x bar minus mu over sigma over the square root of n. Okay, so it kind of depends on what kind of data I'm using. Okay? So, but this, since I'm using p, I'm going to use the p equation. If I was using x bar, I'd use the x bar equation. Okay? All right. So this is the equation. Now, so p is 0.5, p hat I don't know. Z, if my alpha is 0.05, can I know my z? How? So we can open up my thingamajig here. My tables here. If I open up my, so this is a normal distribution, right? So I go to the normal table. Am I doing a left-tailed or a right-tailed or a two-tailed test? That's where the picture comes in. I'm doing a left-tailed test. So alpha is 0.05. Left-tailed test, what value did I get? So this is, if I convert this to a normal, standard normal, that's a 0, that's a negative 1.645, right? So essentially what I'm doing here, negative 1.645, maybe I'll get rid of my camera, or bring my camera back here, stop sharing, equals p hat, I'll leave that as p hat, I'm going to call this p reject, my p hat rejection region, minus p, which is 0.5, divided by the square root of 0.5 times 0.5 divided by, oh, I didn't tell you my n. I have to tell you my n. My n was 500 students. Okay, so 500. Okay? All right, now I just have to solve for my P rejection region. Okay, a little bit of algebra. I multiplied by the denominator. I'm going to put D for denominator, and then I add 0.5 plus 0.5. Okay, that's going to give me my rejection region. So if I open up Excel, open, share. Why is that taking so long to open? Because it's also on spring break. I opened up two of them. Okay, so my denominator is the square root of 0.5 times 0.5 divided by 500. I'm going to multiply that by negative 1.645, and then I'm going to add 0.5. Okay, so this value is 0.463. Okay, so this is 0.463 right there. Okay. All right, so now this is where the picture becomes so important, okay? Now, under my alternative hypothesis here, I'm going to pick a color like, hopefully red. Oh, good, I got it red. Hopefully it works. Okay. The alternative hypothesis says P was not really 0.5, it's actually 0.48. So 0.48 is between 0.463 and 0.5, right? So that's here, 0.48. So what we're saying is, well, the original hypothesis was wrong. It's really less than that, okay? And so the area of the type 2 area, rejection region, is essentially this area right here, okay? Does that make sense? So it's the opposite. So a picture, that's why I'm going to change that to step number 1. This is just critical. You've got to draw a picture because you've got to understand what's going on. So I need to find the area of this red area. How do I find that, Trevin?
I don't know.
You don't know? Spring break erased your memory? What am I picked on? Sure. David? Not 1 minus 0.463 because it is, the area is going to be 1 minus the area, but remember these are actual values, not the standard values. But you're kind of on the right track.
Could you just put 0.48 in place of?
Yeah, we're going to use this equation again, but now instead of 0.5 for P as we used right here, we're using 0.48. Okay? All right, and okay, so in this case, Z equals, Eric, you want to take it away?
0.463 minus
0.463 minus
0.48 divided by 0.48
very good.
by 0.52.
0.48 times 0.52 divided by 500. Okay, so we're going to convert this back and we're going to figure out what 0.463 is based on when we think that 0.48 is really the correct value. Okay, so let's use that in Excel. Okay, and since I still, this is my P reject, P underscore reject. Okay, so this is going to be P reject minus 0.48 and the square root of 0.48 times 0.52 divided by 500. I'm going to take the numerator divided by my denominator. I should underline that. Okay, so this gives me a z-score of negative 0.751. Okay, so this value here is negative 0.751. Now, how do I find this area to the right, David? 1 minus. So if I'm using the computer, 1 minus what? No, that's the z-score. That's not the p-value. Norm est. Remember, besides the fact that it's got to be positive, norm est dist. Oops, what did I do wrong there? Equals 1 minus norm est dist of that. Okay, so this value here in red turns out to be 0.77 3726. Okay? Is it coming back? This is kind of a good review. Okay, yes.
So to do all of this, you always have to have a given alternative hypothesis that's correct, right? Like we couldn't do this if you didn't say.
You need, I don't want to say it's correct. You need a specific value to use. You can't just leave it vague saying it's less than 0.5 because you need to plug this value in to here. Okay? So it seems like, so the idea here is, and I'm kind of glad Eric used the A word the first time, okay, because I want to illustrate something. So the idea here is, let's go back to my picture for a minute. Okay. Now as we look at my picture here, okay, if this blue area is my alpha, okay, if the blue area is my alpha, if I make the alpha smaller, what happens to my beta? Oh, this is beta, by the way. If I make the blue area smaller, what happens to the red area? It gets bigger. If I make my my beta smaller, what happens to my blue? It gets smaller. Okay. So now, so you kind of robbing Peter to pay Paul. If you want to have a smaller alpha, you get a bigger beta. If you want a smaller beta, you get a bigger alpha. Okay. Now the idea here is, ideally, if you have two curves that look like this that don't overlap at all, okay, you could have a ridiculously small alpha and a ridiculously small beta, right? And in that case, you would be very confident you weren't making a mistake. Okay? It's when, in this case, you're kind of in between your rejection region and your mean, you're going to have a big beta. Okay? So your alpha might have been small, your beta is huge. Okay? So you might be 95% confident that you're correct, but you're 75%. Your type 2 error is 77%. Okay. Now, by the way, I should also mention a thing called power. Power equals 1 minus beta. Okay. If your power is greater than, I would say 0.9. Usually, you want it to be greater than 0.8. If it's greater than, say, 0.9, you could probably use the A word. Okay? You could accept, okay, that you were not making a mistake. Okay? Generally, you like your power to be at least greater than 0.8. Okay? In this case, so what's my power in this case here? It's 1 minus 0.77. If I share my screen, my power equals 1 minus that. So I've only got 22% power. I've got low power on this test. Okay? Does that make sense? Golly, we ended up through that really quickly. What I'd like to do, I think.
So with this, like, with the power being, it's very weak. How
yeah, it's got low power. Yeah, low power.
It's not very likely, or.
So you may not make a type 1 error, but you probably would make a type 2 error.
Okay, so
That's what
with
that
low
means.
power, probably going to make a type 2 error.
Probably going to make a type 2 error, even if you don't make a type 1. Okay? It's got high power, you're not going to make either error. Okay? Let's do another one. Oh, this will be good. Okay, I'd like to do a two-tailed test just to show you how that works. Let's just open up Excel. Okay. All right, let's do an example here. Suppose a company wanted a mean weight of candy bars to be 20.1 grams. And the label is 20 grams, but they want to be sure. They give the customer more than they're asking for, right? Okay? All right. Suppose the standard deviation is 0.75 grams. QC engineer wants to know if weights are too high or too low. If they're too high, the company's losing money. If they're too low, they're going to get in trouble because somebody's going to complain that they're shorting the customers. Okay? So, find the probability of a type 2 error if the weight is 20.3 grams. Okay? How would we do such a thing?
So is the 20 grams here, is that the mu, and then the 20.1 is what they want it to be, that would be the X bar?
That's a good question. In fact, we may want to go through here and label these. Okay. So the 20.1, what equals 20.1? What letter do we use for that? S, mu. Who says S? Somebody said S. 1. Okay. Who says mu? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who says P? Nobody? Okay, it's mu. Okay, what's 20 grams? It's your label claim, and it's actually useless information. Well, not useless, but it's not helpful for our problem. Okay. What's 0.75? Which standard deviation? This is our sigma, right? Okay, we're assuming that's a population. QC engineer wants to know if weights are too low or too high, and the probability of a type 2 error given the weight is 20.3 grams. Okay. So what's 20.3? That's going to be our alternative hypothesis. Okay, but in order, and I didn't label that very well, but let's do that properly here. In order to do this, you need to know what is the original. Let's talk about the original null hypothesis. What should be the original null hypothesis be in this case? H sub 0. Mu equals 20.1. What was your original alternative hypothesis? Mu does not equal 20.1. Okay. What's our alternative hypothesis we're going to use? It's 20.3. Here I'll say mu equals 20.3. Okay. All right. What kind of a test is this? Is this a one-tailed or a two-tailed test? Two-tailed test. Remember? Because of this right here. Okay. All right. Now, for those of you who want to draw pictures and you don't want to get in trouble in the testing center and you want to do this on the computer, here's how I would do this. Okay. First time on video. Okay. Remember, you can draw pictures here. If you go over here and you go to insert, oh, you can't really draw very well. Here's what I would do. I wish they had a freehand drawing thing. Well, this is what I would do. Okay. Draw a line here. And this is just going to be kind of triangular. Oh, can you? Oh, actually, arc. Scribble? Will it let me scribble? Oh, it will. Oh, I didn't know it would do that. Nice. Okay. Good enough for what we're doing. Okay, it will draw. I didn't know that was there. That's really cool. Okay,
We must do chi-squared.
we're not doing a chi-squared though. Yeah. All right, we're not going to do this with a chi-squared. It's hard enough with a normal distribution. Okay, all right, so what should be the mean of my picture here? Oh, insert, whatever, I'll just draw a little line here. What's that number there? Mu equals 20.1. Thank you, Trevin. Okay. Now I need to find my rejection regions. If I insert here, this is a two-tailed test, right? So if I insert, in this case, my shapes and a line here, I've got a two-tailed test here. I'll draw a line there, and I'll draw another line over here. Okay, I've got a two-tailed test. Okay. So anyway, how can I fill this? Let's see. I don't think I can fill that. Anyway, that's probably good enough. Now, I've got an alternative hypothesis in here that says, I'm going to pick another, can I pick another color? Let's see if I can do this. Oh, we're going to do the scribble again, the squirrely thing, okay? Hopefully, what I'm going to do here, so I think that the value is a little bit higher. Sorry, I shouldn't have done that again. Let me do it again here. So I think the value is probably going to be something like this. Okay? Now, in this case, I'm going to make that orange. Perfect. And I'm going to make this new font here. This is way too much to do. But my alternative hypothesis is going to be mu equals 20.3, right? So the area here that I want to shade, whoops, is basically, this doesn't work as good as paint, I'm sorry. If I take this up here, this is the rejection region, right? Okay, so I want, in fact, the easiest way to do this is I want basically, well, it's going to cop that in the middle, isn't it? Here's what I'm going to do. I'm going to resize that. Now, good enough. The area that I want here is this area here in yellow, roughly, plus that little piece there. Okay? I'm looking for the shaded orange area basically here. This area here. Does that make sense? If I could do it and paint it would look better, but that's good enough for what I'm trying to do. Okay? All right, so how do I find that area? By the way, this needs to move over here. Okay? How do I find that yellow area? What's that? Okay, I've got to find both rejection regions first. I've got to find, let me make this long here. Okay, I'm going to make this long, and I'm going to make this long here. I need to find those two values. Okay, how do I find those values? So here's where, yeah. So basically I've got this here. So I'm going to use, remember the first time I used z equals p hat minus p, but I don't have a p in this case, right? So I'm going to use z equals x bar minus mu over sigma over the square root of n. Does that make sense? But I've got to do it twice, okay? So the idea here is, let me go back to my thing here. I've got a two-tailed test. Two-tailed test, alpha is 0.05. I'm going to get these two values, 1.96, okay? So negative 1.96 equals x bar on the left, minus mu, which is 20.1, divided by sigma, which is 0.75, divided by the square root of, oh, do I not have an n on this? I forgot to give you the n again. The n is going to be 11. I forgot to give you the n. N equals 11. Okay? All right, so now I just need to solve for this. Okay, so I'm going to take equals negative 1.96 times 0.75 divided by the square root of 11. And then I'm going to add that plus 20.1. So this variable value here on the right is 19.65. 65678. Now this area on the right is going to be exactly the same. Everything's going to be the same, except for this time, it's not negative 1.596, it's positive 1.96. So this value here works out to be 20.54322. Does that make sense? Now, I've got to find this area here in yellow, okay? So the idea here is now I'm going to use this exact same equation again, but this time my mu is not going to be 20.1, it's going to be 20.3. Okay? So now, in this case, I'm going to add 20.3, and wow, that's a, oh no, it's not. I did this wrong. It's the same equation, but my x bar is going to be, it's going to be this value here on the left, 19.65 minus 20.3 equals 0.75 divided by the square root of 11. That's going to give me my z-score of that divided by that. Okay. And then I'm going to do equals norm s dist of that. Okay. I'm going to do the same thing on the right side. But this time, my value is going to be not M21. It's going to be, oh, it is going to be M21, 20.54. Wow, that worked out really well. So now my probability of a type 2 error equals this number minus that number. So probability of a type 2 error is 0.856. What's my power? 1 minus that. So once again, I've got low power.
It's always 1 minus.
It's always 1 minus your beta. Yeah. Okay. So I will post this up. Quiz tomorrow is on 10.6. Oh, I don't know. I think chapter 10. Didn't we start with chapter 10? Yeah. All right. So see y'all tomorrow.